And we have Dr. Ernest Thiessen. He is the founder, if you will, of this whole program that you're going to interact with today. So you're in for a treat. You're in for an interactive treat here, and you will become involved in this process. Mediation, arbitration, conflict. They say the next great war will be on water. So perhaps this may be a tool that will be of great value to you as you step out from this room later on. So Ernie has quite a unique background. Really an engineering systems analyst, as you see, a PhD from Cornell University, where he developed this whole process that we have in front of us. So he therefore is the inventor of the Smartsettle and negotiation system that we're going to use today. And therefore the founding president and CEO of iCan Systems, Inc. Bernie comes out of the West Coast area, so we'll forgive him for that. He's director of Summit Negotiation Society, repeat speaker at the United Nations sponsored forums on online dispute resolution, and deals with water conflict management and as a lecturer for UNESCO. And so very, very background. So, Smartsettle roots, 1980s, and I'm going to let Ernie just come up and tell you a bit about that, because you need to understand where he's come from, where he's going, and his thoughts and ideas about hydropower, irrigation, and the two competing demands for water that led him into this.
Okay, well this all started in the 80s when I was an agricultural irrigation engineer as a volunteer for Mennonite Central Committee working in Nepal. Very interesting project, and we had to do it the hard way in those days. But it is possible to do it the hard way, it just takes a long time. And you know, there was conflict there, and we were a bit concerned, but eventually this project won the UNESCO 2005 Blue Planet Prize, so we were proud of that work. But I came out of it thinking there's got to be a better way, and I attended Cornell University after that, and was looking for a topic for my PhD dissertation. My major professor, Pete Laux, gave me a challenge. He said there's a huge gap between engineers and decision makers. Could I do something to address that gap? And essentially what you'll see today is the culmination of 2 decades of work, not only my own. I've had a team of very brilliant people around me. I could have never done it by myself.
I'd like to retell a familiar tale called the Orange Quarrel to illustrate what we mean by beyond win-win. This story is adapted from Getting to Yes by Fisher and Urey at Harvard University. It was a rather explosive situation because 2 children were using adversarial methods that ignored the interests of the other party. Both children wanted the only orange, and they were heading for a lose-lose situation, destroyed orange, or at best, win-lose if one child overpowered the other for the whole orange. Fortunately, a clever mediator came along with a good idea. Jenny cut, Joey choose. This was a good solution and a win-win solution compared to what could have happened in an all-out fight. All things being equal, this seemed like a pretty fair solution. Both children got 50% of what they wanted. But it turns out that we can do even better than this when we recognize that there are 2 important objectives that help us achieve superior agreements: fairness and efficiency. Divide the benefits fairly and don't leave value on the table. The children in this conflict were using adversarial methods, assuming a one-dimensional model of negotiations. Both children wanted the whole orange, and the problem was that if one was to get more, the other had to get less. The first step in solving this problem is to relabel these scales. Instead of thinking that each child wants 100% of the orange, consider rather that each child wants to become 100% satisfied. Now we can take these scales and reorient them so that we're viewing the case in multidimensional satisfaction space. Now it's no longer necessarily true that one party has to lose when another one gains. Recall the solution in our previous scenario. We did achieve our fairness objective. Both parties got 50% of what they wanted, but when we plot this solution on the graph, we see that there may be room for improvement. To further explore this, we dig a little deeper into our bag of interest-based principles and ask each child why they want the orange. It turns out that Jenny isn't interested in eating the orange. She wants to bake a cake that calls for the peels of exactly one orange. Joey, on the other hand, can never get enough oranges to eat, but always throws the peels into the waste bin. So now you know the optimal solution. Give Jenny all the peels and Joey all the fruit. They both get 100% of what they wanted, which achieves our efficiency objective. Now, wouldn't it be nice if all our problems were that simple? Most of us here would be out of a job, and we wouldn't need Smartsettle. Real cases are more complex. These types of problems have what we call an efficiency frontier. Very rarely can you get 100% for both parties, but you can almost always get more than 50-50. Smartsettle's objective is to find a fair solution on the efficiency frontier. The first person to get credit for a solution to the problem of helping negotiators reach a solution that is both fair and efficient was a brilliant mathematician named John Nash. You may have seen the movie A Beautiful Mind, which tells the story. Nash received a Nobel Prize in 1994 for work that he did over 40 years earlier at Princeton University. His most notable work is summarized in 2 papers. In the first paper, Nash said, "Without cooperation, competition leads to a non-optimal equilibrium." This non-optimal equilibrium has come to be known as the Nash equilibrium. In the movie, Nash shows the paper to his math advisor. The professor says, "This flies in the face of 150 years of economic theory." He was referring to the classical economic theory of Adam Smith, who argued that competition leads to efficiency. Smith said that self-interest could be led by the free market to produce the common good. Nash wasn't satisfied with proving that the status quo is inefficient. His next challenge was how to reconcile his conclusions with prevailing economic theory. His goal was to show how to move from the Nash equilibrium to an optimal solution. In his second paper, Nash wrote, "With cooperation, negotiators can achieve a fair and efficient solution by maximizing the utility product." Maximize the utility product was the name of his algorithm, which, applied, can transform a non-optimal solution to one that is fair and efficient. You may be wondering why this idea hasn't taken off yet. After all, it's been over half a century since Nash explained how to do it. Great discoveries or inventions are not practical to implement unless they form part of a complete solution. As it turns out, there are also other ways to solve this problem. Professor Emeritus Howard Rafa at Harvard University documents a number of these methods in his publication Negotiation Analysis. Rafa is considered by many as the foremost authority on this subject. One of these methods, called Maimonides, was developed by Robert Aumann, who was a recipient of a Nobel Prize in 2005, although not specifically for this work. Rafa's preferred method is called Maximize the Minimum Gain. This method has its origins in Dr. Ernest Thiessen's research at Cornell University and is implemented in the Smartsettle negotiation system. Here's some data from that research. Some parties negotiated without the computer, and others negotiated with the computer. As predicted, those that used the computer reached the efficiency frontier. Let's pause it right there for a moment. This is a significant difference. If you haven't already implemented eNegotiation as part of your process, there's a good chance your deals look like the points in white here. The data revealed a 16% gain over traditional methods for each party. Nash correctly identified the essential ingredient as cooperation, but that has remained rather elusive. Dr. Barry Court at Cambridge said, "Moving from competition to cooperation remains an unsolved problem in game theory." This highlights the problem of bringing negotiators together in the first place. The alternative dispute resolution community is doing a good job of promoting cooperation through mediation, but mediation has not yet been widely adopted. Real people with real conflicts have had too many objections. I can't be sure that a mediator is really neutral. I wouldn't trust a mediator with my confidential information. No mediator is smart enough to understand our problem. Can we overcome these objections? Suppose this represents a complex multi-party problem. Smartsettle reduces inefficient direct communication by introducing a neutral site on the internet which manages all confidential data. Private data is kept safe and secure. Transmissions are protected with bank-grade encryption. The server has all the power needed to solve large, complex problems between any number of parties, negotiating conveniently, anywhere, anytime. Neutral, trustworthy, and smart. Smartsettle provides the mechanism to encourage parties to move freely from mutual distrust to effective collaboration. Like Adam Smith, it does not require parties to give up their self-interest, nor does it require them to give up their freedom to choose among alternatives. Like John Nash, it knows that collaborative methods produce greater benefits for everyone and can prove it. Unlike anything else available on the market, Smartsettle can deliver those increased benefits to all parties now.
Ordinary negotiations suffer from 4 serious problems. Russ, how would you like to play Micah here?
I'm going out with friends. I'll be back later.
When's later?
No, whenever we're done.
It's a school night, Micah. I need a time.
Let's say 11 o'clock.
Let's say 9.
1:30?
9:30?
10?
Okay, 10 it is. And they both love it when they win. And these 4 quadrants actually illustrate the 4 serious problems that are characterized by ordinary negotiations. Relationships are harmed by using inappropriate tactics. Weaker parties are inhibited by a power imbalance. Huge amounts of time and money are wasted with a tedious negotiation dance. Significant value is left on the table and outcomes are unstable. I've been involved in research and development of a product now called Smartsettle over the last 20 years. And we actually have 2 products, a very simple one for simple single issue negotiations, mostly to deal with money, and then Smartsettle Infinity that can deal with the most complex cases. And we're actually going to show you a demonstration of Infinity today. So the goals for when we apply this system to cases are to reach fair decisions, don't leave anything out, be comprehensive, do it properly and legal, be efficient, better than just fair, and document with a formal agreement. And
it's a collaborative, non-adversarial,
voluntary process, and has all the good things that you would expect from that type of a process. And then there's the additional benefits from being able to continue online. The process can start face-to-face, but it can continue efficiently online. So I'm going to be talking about the process a number of times in a number of different ways. So here's one way with a number of points. Prepare for negotiation, build a team, identify problems, develop objectives, and then create a framework for agreement. This framework for agreement is like a final agreement, except there are blanks for the unresolved issues. Issues are defined, and you can formulate alternative plans here, and then build a model for evaluating plans, elicit and analyze preferences. We have a methodology called even swaps, which I'll show you later on. And then they're ready to exchange visible, optimistic proposals, emphasizing visible, because in the process there are also suggestions generated on which parties can indicate their acceptance. So these proposals are used to establish and narrow bargaining ranges, and the goal is to reach a tentative agreement. That tentative agreement if the parties can agree on the status quo and accept it as a reference, then that's preferred, and that's the easy way. But if not, then you might be stuck with a difficult time trying to establish what is fair. We have a process called visual blind bidding, in which suggestions are generated, the parties place hidden acceptances on those, and when parties accept the same package, then you have a deal, and it's also very amenable to another process that is able to actually solve the impasse if that doesn't lead to a solution. And finally, improve and implement a good plan, ensure the final agreement is fair and efficient, and this is application of optimization. So this represents this picture, the Smartsettle eNegotiation system. You can maybe think about it as a table to which all the parties come to negotiate. But it's not a simple inanimate table. Associated with this table are sophisticated algorithms. And if you can read that from there, you can see this looks more like a recipe. In fact, an algorithm is not much different than a recipe. Or you can actually think of an intelligent agent that's there present at the table with you, or simply some special sauce, and that's you have skilled facilitators that just use that special sauce to come up with something good. So a system that's smart, neutral, trustworthy, safe, secure, anywhere, anytime, in order to come up with a deal that's even better than fair. Two objectives for superior agreements: fairness, provide the benefits fairly, and efficiency, don't leave value on the table. Smartsettle addresses these objectives with an early intervention process that encourages and rewards collaboration. So here's another picture. It's a flow diagram showing you again this process for fairness and efficiency. The first step is to prepare and gather information, and then summarize the issues. And once you've got a list of issues, you're actually ready to start negotiating. But it's important to develop a good framework for agreement. So this task can actually be a relationship building exercise. Don't focus on solving issues, but rather build this framework for agreement that's like the final agreement, only it has blanks for the unresolved issues. And then they go around this circle a number of times. That yellow circle can identify outside processes for the particular application that should be respected in the process. But once they've got the words right, then they're ready to come to a final agreement. They're advised. They make sure the parties are sure to be adequately informed, and with that information, then they can come to a binding agreement. And if there's value left on the table at this point, then we can approve it and finally end up with a signing ceremony. So here's another view of the Smartsettle process. This is a multi-dimensional satisfaction space. You have the satisfaction of party A plotted on the vertical axis, and the satisfaction of party B plotted on the horizontal axis. Sorry, that's actually a little hard to read there. So there's now a walkaway for each party plotted on this curve here, and the parties are looking for a level of satisfaction that is better than their walkaways. And the process starts with optimistic proposals that may end up outside of that zone of agreement. So neither of these optimistic proposals are actually acceptable to either the parties given those particular walkaways. And then the system can generate suggestions. Those suggestions may fall inside that zone of agreement or outside. Parties accept some of those packages, and then there's an algorithm that decides which one of those becomes the tentative agreement. If there's value left on the table, then there's an algorithm maximize the minimum gain, takes them up to the efficiency frontier. We'll see that once more after I talk about a process called visual blind bidding. So this is a process by which we can help the parties actually solve the fairness objective. And it can be applied to a single issue negotiation or a negotiation of many issues. So let's just think about that problem of the orange quarrel. And just imagine that there's just one issue for the moment. And they're arguing about who gets how much of that orange. And the issue is, how much should Jenny get? And Jenny is saying 30%. And Joey says, no, I only want to give you 10% of that orange. And so the question is, where is fair? And we assume it's somewhere in between those two values. And now, if there was some good objective criteria to apply to that, that would be a good way to determine what fair is. But often, objective criteria doesn't come to the rescue, and you're stuck with this tedious negotiation dance. And what Smartsettle does is it replaces that tedious negotiation dance with a process called visual blind bidding, in which suggestions are generated. So here are a number of suggestions that are generated between those two proposals. And on these suggestions, the parties can place hidden acceptances. So neither party knows which value, or package actually, has been accepted by the other party until they both accept the same value or package, and then you have a deal. So this looked like a single issue negotiation between 0 and 100%, but you can actually imagine these points on this single dimensional line here as actually representing packages. They could represent a rating of a whole package of different issues. So that's why it says here it works with any type of negotiation, any number of parties, any type or number of issues. And then there's that reward for collaboration that I mentioned. Of course, the big reward is the deal itself. If the parties are both collaborative and they come quickly to this deal, then that is certainly the reward that they're looking for. But if one party is more collaborative than another, there's a reward for that party that shows more collaboration. We're going to zoom in here to the last two sessions of the process and see how that works. So Jenny accepts a value of 21. Now remember, that's hidden. Joey doesn't see that. He accepts a value of 15, and session 1 ends. There's no deal yet. So now Jenny says, we've got to solve this. I'm declaring final session. And Joey makes a large move and says, oh, I'm willing to accept 25. Remember, I'm going to remind you that that is hidden. Jenny came to 19, and now there's an overlap. We call that overlap the zone of agreement. So we've obviously got a deal, but what is it? The obvious thing would be, well, just split the difference. Call it 22, but it turns out that the split the difference algorithm tends to produce a chilling effect on negotiations. So we thought, what can we do to actually avoid that chilling effect? And we came up with an idea that actually produces the opposite effects. It encourages parties to move quickly to the zone of agreement, and that is to reward the party who moves most quickly to the zone of agreement. Or and it's actually equivalent to rewarding the party who made the smallest last move. Smartsettle considers the party that made the smallest last move as the most collaborative. And that, in this case, that was Jenny. Joey was holding out until Jenny declared final session, and then he made a large move. So Smartsettle rewards Jenny by declaring the final agreement to be 24. And you can see that the benefit that's distributed there at the end is in the same ratio as the size of their last moves. Now, you might say, well, that's all fine and good, but what happens if there is no agreement in this particular process? What if we back up a session and say it ended here, where Joey was at 15 and Jenny was at 21? Well, an agreement can still be guaranteed if the parties agree that there will be arbitration in final session if they happen to not come to an agreement. And the particular type of arbitration that's used in the Smartsettle process is called dampened pendulum arbitration. It's like pendulum arbitration, sometimes known as baseball arbitration or last best offer arbitration. If you're familiar with that, you know that the arbitrator is told to either pick 15 or pick 21. And so then that gives an incentive to the parties to make sure that they're not a long ways from fair when they end up, because they know the arbitrator is going to pick one of those. But the reason that this type of arbitration is not used more is it has one problem, and that is it identifies a clear loser. So again, we said, well, what can we do about that? Because you know, it's great to give them the incentive to come to close to fair, but what do we do about that problem about identifying a clear loser? So the way dampened pendulum arbitration works is it uses the opinion of an expert neutral. And that expert neutral identifies fair on this scale. That expert neutral doesn't know that Joey is accepted 15 or that Jenny is accepted 21. That expert neutral is given a range of values to choose from, and their job is to identify fair, and then what Smartsettle does is then rewards the party that's closest to fair. In this particular case, it was Jenny, and when the deal is declared to be 20, she's rewarded. But you know, neither party knows actually what happened, because remember, those values were both hidden. But they know how the process works, and so that's the main thing. It rewards fairness, minimizes the need for arbitration, and minimizes the clear loser problems. So we've been thinking about a single issue negotiation here and trying to relate it to multiple issues, but let's add a few more issues here. We had the fruit to Jenny, and you know the story, but they actually became interested in that peel as well because Jenny wanted to make that cake, and there could have been some other issues as well, like who peels the orange, and how much cake is Joey going to eat? So after the issues have been identified and the framework for agreement is established, then what Smartsettle needs to know is what's important to who. So these are Jenny's bargaining ranges here. She says this would be the best of all possible worlds here, and on the other side is the worst. So she identifies some private bargaining ranges. Joey is doing the same thing over there, and they're both saying, we're going to expect the outcome to be somewhere here. And so once they've got those private ranges identified, then Smartsettle needs to know how important is each one of those ranges. So in Jenny's case, as you know, she wasn't very interested in eating the fruit, and she really wanted the peel, so she puts 10 points on the fruit, 90 points on the peel, and only 20 on each of these. If she gets everything that she wants, how many points does she get? 140. As opposed to, on the other end, 0, but she's expecting a solution somewhere in between. Momentarily, we're going to actually show you how Smartsettle Infinity would solve this problem, even though you would never use a sophisticated program like that to solve such a simple problem. It's just mainly to show you the process. But let me show you this once more. we've got Jenny on that axis. She wants to be as high as possible. We got Joey over here. He wants to be as far as possible this way. And they've each got a walkaway. So there's a walkaway plotted for Joey and a walkaway plotted for Jenny, and that defines a zone of potential agreement. They're looking for a solution somewhere in there. They exchange those optimistic proposals. Smartsettle generates suggestions. So we're going to actually see this in the interface momentarily. So I'm telling you what I'm going to tell you, and then I'm going to show you what I just told you. And Smartsettle is going to choose one of these. Let's suppose they accept all of these packages, and Smartsettle uses that algorithm that I just defined a couple of minutes ago to choose one of these, and by rewarding the party that moved most quickly into the zone of agreement, that becomes the tentative, and then if there's value left on the table, we go out there and use that algorithm, maximize the minimum gain to produce a solution on the efficiency frontier.